Hi, Course 3. Today we're working with sort of a patterned list, or what we've learned to call a sequence again. Starts with some review, and then we add just a little something to these sequences. So if you recall about sequences, all right, we make this chart, like a tipped over T-chart, where we have the value itself, like 3 or 6, the actual values, as A. Okay. Then we have this cool thing called N. N refers to where it is, its position, right? Its number in the list, which is always 1, 2, 3, 4. You always know that. And using those combined, we can write a formula. In this case, maybe you would say the formula is position times 3. So we could write this somewhat well-known, familiar formulas, and this little n is just a subscript. It's not involved in calculations. But we would say value would be position times 3. Because if I want to find, the fourth number, for instance, then that would be A of 4 is 3 times 4, right? And that would be 12, which we see is right. Now, you could also write this as what we call a recursive formula. Recursive means we're going to write the formula not necessarily only in terms of position, but also its relation to the number before. It's kind of fun, actually, really looking over it this way. Because instead of writing it as 3n, we could also, with recursive formulas, use a plus sign. What this formula is saying is the value of a particular term is 3 added to the previous number. This means the previous number. Can you figure out why? Instead of its position, it's its position minus 1. For instance, if I'm talking about, I'm trying to find the third number, I can talk about the number that came before because it's the third number, but then it's minus 1. The number that came before is the second number, right? But we don't always know what that is, so we just put A as n minus 1, and then we add 3 each time. That's called a recursive formula. We add 3 to that number, to the previous number's term, to find the new number. Now, to do that, we generally want to have what's the value of the first term. Okay, A1, or the first term, value in the 1 position, is 3. And when we know that, and this, right, we can find any of them. So if we want to find the 5th number, so that's this, we go A of 5 is A of 4 plus 3. Okay? Now, it's a little laborious because to get to the 4th term, we're going to have to use the 1st term, to get to the 2nd term, to get to the 3rd term. So, if A of 1 is 3, that means A of 2 is A of 1, or 3, plus 3. So A of 2 is 6, right? So now we're at 3, 6. And if you figure out the pattern that it's just plus 3 each time, then we count until we get to the 5th term, and we're there. So there's a little bit of work there. Today, we're going to especially just be writing the formula themselves. So here, what's the pattern? We add, actually, we don't add, we multiply by 2. So instead of using addition, this recursive formula writes a formula in relation to the previous term multiplied by 2. The term in the whatever position is 2 times the previous term. That's what this is saying. Understanding value in the position of 1 is right here, right? It's 2. So to review that without all this extra help here, they give us that sequence and they say write the recursive formula, not just any formula, but make it recursive, meaning we need this in there somewhere, right? The value, we always start with that, just like before, is this. Now, how does this relate to the previous number? It's times 2 every time, isn't it? Now, the first term being 2 is also important, and we show it with this little brace. That's how we did that. This shows how to find any term of a sequence right here. Use it to find the first 4 terms of the sequence. So n, 1, 2, 3, 4, a, we don't know yet. But when n is 1, a will end up being 3, right? When n is, for example, 2, a is gonna be 5. When n is 3, 6 plus 1, it's 7, and I'm guessing this is gonna be 9, yep. Now, a recursive form, so that's the beginning of our answer. Maybe put braces 3, 5, 7, and 9. Then the recursive formula has to show something in relation to the previous number. So a of n is the previous number, looks like a plus, right? Every time we add 2. With the first number being 3. You put your brace on there, we're done. A little messy, sorry, but I want to get to this last one. Here's a recursive formula for a sequence. We know the first term, and we know the recursive formula here. Find the second and third terms. Okay, just to keep things organized, I'm going to set up our chart again. We're going to need 1, 2, and 3. We know a of 1. A of 1 is 5, according to this. With that, what if it's a of 2? That'll be 3 times a of 1. We know a of 1 is 5. So I put that in here. A of 2 is 15. Follow that, a of 3 is going to be 45, right? Because that's a of 2. So that's recursive formulas. It's all about showing the pattern in relation to how it relates to previous terms, where the subscript is position n minus 1. Let's do A, B, and C. Don't have to do D.